Okay, so if you guys notice, I put up the answers to our homework on the board. So we have example 5, 6, and 7 from our guided note sheets, and then 4 and 5 from your worksheet. So what I would do is get out your homework from last night and start checking these answers and letting me know if you need to go over a few things.
Could have been.
So I did out examples 5, 6, and 7 so you could see how I went through several different questions. Just so you could see the work. And then 4 and 5 I just wrote up the answers because that would have taken a lot more board. But if we need to go over those, we definitely can. So with example 5, I'm trying to solve for f of g of x. So I'm plugging the g of x function into f of x as the input. So I was working with Andrew a little bit earlier, and it's really helpful for me to write it as f of the actual function. So I just substitute in the function for g of x. So I know that this is becoming my new input for x in my f of x function. So here when I do this, I have the cube root of x plus 4 cubed minus 1. And then when I simplify, when I cube a cube root, it just becomes x plus 4. It cancels out. X plus 4 minus 1 becomes x plus 3. And my domain is all real numbers for that. Do we have any questions on part A of example 5? Excellent. So then working the opposite way, gof x or g of f of x, I then plug the function f, or x cubed minus 1, I plug that in as the input for g. So I can say g of x cubed minus 1, which means that I plug x cubed minus 1 in for x in the g function. So if I do that, I'm plugging it in for x here. So it becomes the cubed root of x cubed minus 1 plus 4. As simple as it gets is cubed root x cubed plus 3. I can take the cube root of any number or of any like positive or negative number or 0, so my domain is all real numbers. If this was a square root, I'd have to make it so that x would be such that this doesn't equal less than 0. But because it's a cube root, x can be anything. How'd you guys do with the inputting of a number instead of a function?
That makes more sense to me than
this.
Yeah.
Because it's a number, it's like a
direct.
step and then a step instead of like plugging in like
When you write
cube
it
root
all
of
out,
x
you
plus
write
4.
less stuff.
Hmm?
When you write it all out, you write less stuff.
yeah.
Can we go over 7?
Yeah.
I got 7 wrong as well.
Yeah,
I didn't know I did.
I very much
So on
got it
number
wrong.
7, I've got my two functions. F of x is equal to x squared plus 5x, and g of x is the square root of x minus 4. And so I'm not asking for a domain here because I'm actually solving for a value. So I don't need to write a domain for this. So I'm asking for f of g of 9, which I can rewrite as this. And so in 6, I kind of wrote it out that I can write it out in a darker marker or something that works better. So I'm inputting 9, so input 9 into the g of x function. And then whatever I get for that answer, I then plug this whole thing into the f of x function. So then I plug solution of g of 9 into f of x function for x. So g of 9, I plug 9 into my g of x function, the square root of 9 minus 4 becomes the square root of 5. I can't simplify that any further. I could make it a decimal, but I'd have to cut off decimal points, so this is my most accurate answer. Then I take the square root of 5 And that's my solution to g of 9. So I have to plug this into the f of x function for x. Because radical 5 is also the same thing as g of 9. G of 9 equals radical 5. F of radical 5 is inputted in 2 places. I have 2 x's. So I have radical 5 squared plus 5 radical 5. This cancels, the square root and the square. So it just becomes 5 plus 5 radical 5. That's my most simplified answer. And then for my second one, I solve f of 7. And then once I get f of 7, I plug that answer in for g. So f of 7 becomes 7 squared plus 5 times 7, or 49 plus 35. That becomes 84. Then I plug 84 in for g, or for f of 7, so it becomes g of 84, square root of 84 minus x, so this would be 84 minus 4, sorry I wrote x. 84 minus 4 would become the square root of 80, which I can simplify into radical 16 times radical 5, which this becomes 4, square root of 16 is 4, and radical 5 I can't simplify any further.
I just first do the second.
This,
I just think like 84 is the answer.
mm,
I just do the second step.
that's
Oh,
Oh, so you solved for g of 9, but you
I didn't know you had to put it back in again.
didn't. So I was telling the other class it's kind of like something that sits inside of something else. I was thinking of like a Russian nesting doll, like those dolls where you have like the big doll and then you like take them apart and there's like little dolls underneath. You can like continue. This is the foundation of this for this. Like I have to solve this in order to plug it in to get this. So kind of built off of each other. Do you guys have any questions for 4 or 5 from the homework, from the worksheet? Excellent.
I just need to finish, because I feel like I do it in a very different way than you do, but I get the same answers.
How do you do it?
I
Just
like,
like curiosity.
yeah, I don't know how I do it, yeah. Okay, so like it's really hard to explain, try to
Yeah. Are you okay being on camera?
I don't care being
Hi.
Okay, so like I just like talk myself through it. It's like weird, but if I were to do like number 6, like I have to do like f of g, so I'm like okay, f of, and I put the g function in there, so I'm like x plus 1, and then I like use the f function, and I'm like okay, wait, and I have to plug in like 3 for that. You'll just see.
Yeah, I got you. I got you. I got
So
you.
then like the f function is this. And then it's like I have to put the x out there, so like, but then I plug in the 3 for the x.
Yeah, that's exactly right.
So that's what I do, and then I
Yeah.
solve that.
That's exactly how you do it. I just broke it out into 2 distinct steps and you combine them together. Yeah, it's perfect. So you took this knowledge, like this here, and you applied the number in here.
Yeah.
Is what you did.
So
So you just combined, you synthesized the 2 steps that I was doing together into 1 step, which is perfectly awesome. Perfectly fine and awesome. And if it works for you, keep doing it, because that's totally right. Okay. So on the last square of our notes, so on the guided notes, we didn't cover decomposing a function. Some of you might have filled this out, some of you might not have. Is everyone okay if I erase this? Yeah. So not only can we put functions together and like combine them, but we can also take them apart. Kind of crazy. So in number 8, it gives an example of h of x equals 1 minus 2x to the 3rd power. And it wants to know what could be my possible f of x and g of x functions for that. So like what 2 functions could I combine together? And so when I'm solving these decomposition functions, so in number 8, I have h of x equals 1 minus 2x to the 3rd. When I'm solving these decomposition functions, I'm looking for like a parent function. I'm looking for like what is the parent function, and is there any stuff associated with a parent function? And why do you think I'd look for a parent function here?
It gives you something to like work off of.
It gives me something to work off of. Also, like if I write the parent function here,
Yeah, you already have.
I have an available input x, because remember I'm taking an equation of inputting it for an x value, right? So like if I'm looking for what is the simplest function that can be identified here, what I'm actually doing is how can I simplify this down so I get it so I just have x, so then I can take all this stuff and input it into the function. So for number 8, because I'm looking for f of g of x to equal h of x here. So I'm trying to input a g of x function into an f of x function. So my f of x would be x cubed, and my g of x function would be 1 minus 2x. So when I input g of x in for x and f of x, I get this. So I'm working backwards from where I was before.
Working backwards.
Sometimes working backwards allows you to go forwards more easily.
It's like when you do paper maze, like maze.
Like, how's there
Or like the little race cars that you pull backwards and then
Yeah,
they
you
like
have to go
launch
backwards.
you
But
forward.
then when you go backwards, you go forward even further than you pull back.
I would pull back too far and broke.
So for my step 1, I identify a parent function and its accessories. We're gonna go over what I mean by excess. That's not how you spell that. Accessories. And number 2 is identify the stuff that goes into parent function for x. So for this, I identified my parent function as x cubed. There are no accessories with this one. I'll show you in a different example what that would mean. And then I identify this stuff, which is this. So this is the stuff, which is equal to g of x. This is my parent function, which is f of x equals x cubed. And that's how I would decompose a function. So I'm going to do number 10 because I think that number 10 is a little bit more challenging than number 9. Or I can do number 9 and 10 and have you guys do 11.
Let's do that.
Okay. So in number 9, I have h of x, and again, h of x is this. So I have h of x equals the cube root of x squared plus 1. So what is my overall parent function here?
Cube root of x.
Cube root of x. So f of x equals the cube root of x. And then what's my stuff?
X
Square.
X squared plus 1. And so when I would be talking about accessories, it'd be if I had something like this plus 3 on the outside, I'd have to add that to my f of x function. Because I can't plug anything in like to that added bonus. We'll have that on number 10. So I have my f of x is the cube root of x, and then when I input g of x into f of x or x, I get h of x.
So that's like,
So what
like
happens?
where the x is, you put parentheses and then put g.
Oh, I see what's happening.
Yep, so I would plug this in for this x to get f of g of x or f of g of x, which equals h of x.
This makes much more sense.
Kind of making sense, but where did the stuff come
So my first step for h of x, because I'm trying to break h of x into 2 functions, would be to identify the simplest form so I can have an x to plug stuff into. So I can identify like where can I plug in another function.
Oh, the x squared
So-
plus 1 is the under the rock.
Yes, exactly. So this would be my stuff.
That's
Because I can replace x with this to get this. Alright, number 10 takes it up a notch. Turning on the heat. So h of x we have 4 over x plus 7 minus 1. Boy oh boy, do I have accessories here. So what is my parent function?
1 over x.
So I have 1 over x is my parent function. But if I plug in a different equation for x, how do I ensure I have a 4 here and a negative 1 here?
You put a 4 on the top in the parent function and minus 1.
Yeah, so I have f of x equals 4 over x minus 1. Nice job.
Whoa. How'd you get that? I'm sorry.
So when I'm looking at this, I'm identifying a parent function and the accessories. So if I was to plug in something here, I would still have, because this is the only place of input, right, in a function, the only place where I can replace values is with the x or a variable. So I'd be left with a 1 here, and I'd be left with I'd be left with nothing here. And I want to have a 4 and a minus 1. And so this is my parent function, and then these are my accessories. So it would become 4 over x minus 1, and then my g of x, or my stuff, would be x plus 7. So when I input x plus 7 in for x, I get h of x. And there are several different answers. Like, these aren't the only answers for these. Some of you might go crazy. These are the easiest ways to find the answers. Some of you might want to get creative and like really dive deep into decomposing functions and try it a different way. There are multiple different answers. These aren't the only right answers. But these are the simplest answers for this. Alright, so let's try number 11 on our own, or with a partner.